Hello, my name is George Cooper Jones, and welcome to our group's Fall 2017 AME Capstone project, which, for the lack of a better working title, we are calling Digital Plinko. This project is an interactive digital media installation that explores the relationship between physics, space, and sound, as well as manipulating the way that the user perceives digital and physical space. This exhibit allows users to interact with digitally generated sound and a digitally rendered ball by manipulating physical blocks attached to a large projection screen. The ball, which will be projected onto the screen, will fall from the top and react to the blocks in digital space by bouncing off of them and making a unique sound. The user can influence the path of the ball by moving the physical blocks around the screen, and dropping balls in quick succession will allow for the creation of unique patterns and rhythms that are spatially based. So how do we actually plan on implementing this? The diagram on the left gives a more schematic depiction of what the setup will look like. The interactor will stand on the front side of the screen, while a projector and camera will be located on the opposite side, pointing towards the rear of the screen. The tracking of the physical blocks will be done using fiducial markers that are attached to the backs of the blocks on the backside of the projection screen, and these are detected using the camera. The position values of the blocks will be sent to a physics sandbox in MaxMSP, simulating a ball object, and there will also be matching digital blocks in this rendered world that will be positioned according to the physical locations.
My biggest contribution was the fiducial tracking program. I used Reactive Vision before in the fiducials to track rotation and also to track presence. If it was there, it would do something, and if it wasn't, it would stop doing something. And the biggest challenge for us was getting it smoothed out, and I really am glad we got it smoothed out to work with jit.phys and to be as smooth as it was and to be as reactive as it was. It was a great tool. It's perceiving to be a great tool to use for a lot of these digital physical world installations and projects, and it was great. I think the tracking program came out very well done. I think there's some stuff we can improve on a little bit, but for the most part, I'm really excited and really happy what came out of the project.
And finally, this ball simulation will be projected back onto the projection screen to match up with the physical blocks. The blocks themselves will be attached to the screen using magnets, a magnet on either side that will sandwich the projection material. This will allow for complete freedom of movement on the screen, both the X and Y axes. And by attaching the fiducial markers to the rear magnets and viewing them from behind, we can guarantee that the camera will always have a clear view of them.
Hi, I'm Alex, and thanks for sticking around for the build portion. This is our project right here. This is our Plinko screen, or our play area. It is made up of a simple base and an actual screen. The screen itself is a 16:9 aspect ratio. It's made out of local wood from Ace Hardware, cheap stuff. The styrofoam is reclaimed styrofoam, so it's free stuff. And what's actually holding them on there is the other magnet on the other side, which is neodymium that George picked up from an online market. The actual screen or membrane itself is a frosted shower curtain. We also picked up pretty cheaply. For the base here, again, it's made out of the same sort of wood from Ace Hardware, but we actually added this sort of tray towards the end of the build, as well as these bags to help keep the load down, because we found there was some drag on the screen while blocks were being moved. We also added these supports after the fact as well. In the beginning, I had a bracket on here so I could actually fold this to get it to school. We also took some safety measures while constructing, taking into account any things that might be sticking out. We glued over with hot glue. I also made sure that when I stapled this, to make sure that each staple was really in the wood, not out anywhere. Also, putting this membrane on was a big challenge, but luckily I actually had some experience from stretching canvas in a past class. so that came in handy. That's the extent of the build process. It worked out really well, and the group came together in the end, and we finished the build out. I think it worked amazingly, and I can't wait for you guys to see how it actually performed in Capstone. This is also the interface we had running during Showcase. On the left, there's a level selector where you could select between levels using member keys. Each section triggers a different sound bank for the game to play. And the rhythm section here is a bit more customized with a slider to change note length. On the right, there's a mode select where players could just use the keys here, which would be N, P, and S for normal, pro, and sandbox modes. The normal mode is just basic. Professional would get rid of the elevator on the side, and sandbox here would allow to have changing of gravity as well as the bounciness of the ball in-game. You also have the elevator on and off here just because it is sandbox, and even an inverting gravity setting. At the very bottom here we have a restart level, which you get a quick indicator there that it's restarted. Going behind the patch here, it's pretty simple. I'm just looking for what key is being pressed here, and then that's routing to this message box, which we had going through to the different patch, which was on the same laptop. Down here is the rest of the sound triggering. You can see that it's routed as well to that, so that the sound bank can also be triggered. There's a little bit of stuff here, fancy moves with delay, just to keep the boxes from being triggered multiple times, just to clear the board. Other than that, it is pretty simple. I hope this was informative.
My main contribution to the project thus far has been to develop the 3D environment in MaxMSP that we are using to simulate our ball, object, and our digital blocks. The program reads in position and rotation values for the blocks and outputs collisions between the sphere and the blocks. So as you can see, there are 3 variables that control the position and rotation of each block. Those are easily changeable, and those will be read in from our fiducial program. And we also have our sphere object being simulated in real time. And up in the corner here, you can see that our collision detection detects when anytime that the ball hits a block object.
So for my portion of the project, I was kind of in charge of sound. So when I started off, I downloaded a bunch of samples kind of for the levels that we had in mind. And I know it looks a little messy at the moment, but basically what I would do is I would mute all the other tracks, select what I want, making sure that I have the gain and the volume of the sample selected, and just export that. And this was all done using FL Studio 12. And then after I had all of the samples done, we moved them into their own individual sound banks. So here are the contact samples, and then the background that plays when the ball is first dropped. So there are 6 levels, and each of them all have their own sound banks. We get the contact information from these receives right here, and it's sent into these outlets, the 3rd outlet of each patch, and we have random objects that count through them, and every time there's a bang sent, it plays one of these samples, so it's kind of random for what is played throughout. We have a selector here that was connected to the rest of the GUI patch that you kind of saw from Alex's portion. But yeah, that was my section basically, mainly the music. And then I am currently working on our video at this moment. That is my portion of the project.
So that is a brief overview of our project concept and progress. I hope you enjoyed, and I look forward to seeing this project come to fruition.